Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to today's revision session, especially for grade 10 advance who are going to give the math exam next week. So on your special request, here I am with module 1 revision. From the Haykel, we are going to be covering the first 7 learning objective. We are going to do it in 2 parts. This is part 1, and whatever I'm not able to cover in this session, I will be covering in part 2. So stay glued to the channel, make sure you subscribe so that you don't miss any upcoming videos. Let's get started and see what questions we are learning today. Okay, so we are going to now solve question 1 to 3 from learning objective 2, where you solve quadratic equations by graphing. Now, because the graph is given in this question, we don't need to find the discriminant. Okay, so very easy method. We will use a shortcut because it is MCQ in the exam. No need to do the step. So just look at the graph. Is this blue graph of this function, number 1 question, is it touching the x-axis? No, right? So therefore, in this question, we can directly say it will have complex root and the discriminant will be negative because this graph is not touching the x-axis. So we cannot find any solution. It's like no solution, no real solution. For question 2, however, if you see closely, the graph touches at 2 points. Can you see the points? One is plus 5 and one is minus 2. So there are two real distinct solution. Now, if you actually need to find the solution using discriminant, you also know the formula b square minus 4ac, and you may also use quadratic formula. But since in this question the graph is already given, we can directly get our answer from the graph. It is only asking you to determine the solution, the number of solution and the value. For question 3, if you see the graph is inverted, it is like opposite of a U shape and it touches the x-axis at exactly 1 point. So there will be one real repeated root. Let's look at the value. So this is minus 1, minus 2, minus 3. So this is minus 4. Yeah. So x is minus 4. In this question, x is minus 2 and x is plus 5. Okay. This is how you get your solution. So as I promised, this is the answer key, the proper answer key. These are the steps ideally that you should be doing. But as I suggested, because it is MCQ exam, I would suggest you there's no need to find the discriminant. Just from the graph, you know, because it does not touch x-axis, no real solution. Khalas, that's enough. Similarly, for question 2, even though you can find the discriminant, you can do the quadratic formula. Looking at the graph, you get the two answers, minus 2 and 5 directly. And the last question, the graph touches at only 1 point, so there's a double or a repeated root at minus 4. Hello and welcome to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to today's session. In today's session, we will be solving from your EOT Haykel for Term 3, Grade 10 Advanced, Module 1, Lesson 1-3 questions. So this is learning objective number 3, where you perform operations with complex numbers. In this video, we are going to be covering question 29 to 32 from page 25 of your math book. So let's get started. We'll be covering all the operations one by one. We'll start with addition, then subtraction, then multiplication. So let's begin with the first question. Here you are given two complex numbers. This is the first one. This is the second one. Remember, a complex number has two parts. The real part, which can be any number x without any imaginary part, and the imaginary part which is multiplied with I, which is the iota here, which denotes your imaginary part. So like simple algebra, we have the rule that when we add or when we subtract two complex numbers, we will add like terms together. So we collect the real part with the real part, that is the number with the number and the imaginary with imaginary. For example, in the first question, question 29, the real part of the first complex number is 6 and the real part of the second complex number is 4. So we are going to combine the real part together, and similarly we are going to combine the imaginary part together. So what is the imaginary part? It is the part which is multiplied to iota. So if you see, it is negative here, so minus 3, even here the sign is negative, minus 2, and I already take I outside, means I combine the like terms, imaginary with imaginary, real with real. So let's solve. 6 plus 4 is 10, plus iota times, now there is negative sign, minus 3 minus 2, so it will be minus 5. So your final answer is the complex number with the real part 10 and imaginary part minus 5i. This is how we do addition of complex number. The first question was addition. Let's now do subtraction. So subtraction is also similar to addition. The only difference is that because of the negative sign, when we open the bracket, the sign of the inside term will change. So let's open the bracket. So minus 11 plus 4i. There is no change of sign here because outside there is positive and we just remove the brackets. However, for the second complex number, if you see, there is a negative sign outside followed by brackets. So when we open the bracket, the negative sign changes and inside 1 had positive, so it became minus 1, and here it was negative 5i, so it became plus 5i. So that's what we get after we open the brackets. Now, like the previous question, we will combine real part with real part, so the number with the number. So it will be minus 11 minus 1 combined together, and imaginary with imaginary, so 4i with 5i, so 4 plus 5. So what is the final answer for this one? Minus 12 plus 9i. That's how you do subtraction. Remember, in subtraction, be careful to change the sign. Okay, let's go to another question. Okay, so now let's solve these two questions. These are on multiplication of complex number. For question 31, I will use FOIL method, and for question 32, I will use distributive property. Even though the methods are different, but the answer in both will be same. So you are free to use the one that you find easy. So FOIL, you have studied this in term 1, so it should be easy. F means the multiplication or the product of the first term. So the first term here is 2, here it is 3. Multiply 2 times 3, 6. O is outer terms, means the outside terms. So outside is 2 and minus I. Remember, you have to take the sign also. So 2 multiply with minus I, so negative 2I. I is inside terms, so 3 multiply with I, so that's 3I. And L is the last terms, which is last here, so I multiply with minus I, there is a negative sign and iota. Now in the end you have to add all of them, so let's add 6 minus 2I plus 3I minus I square. Now what's the value of I square? You already know, it's minus 1. So minus of I square will be plus 1. I combine it with the real part, which is 6, and I combine imaginary with imaginary. So 3I minus 2I, 3 minus 2 is 1. So this is going to be 7 plus I as the final answer. Let's do question 32. Again, it will be solved using different method, distributive property, but the answer will always be same. So let's do that also. In this method, distributive property, we break the first term into two parts. So what is the first term? 5 and minus 2i. I break, and the second I copy same 2 times. Now remember, whenever it is distributive property, we have to multiply term wise and make arrows or brackets carefully. So I multiply 5 with 4, this with this, and then there is negative sign, 5 with I. Then minus 2i with 4, you multiply, and then negative negative becomes positive. 2i multiplied by I. Can I write 2i square? Yes. Now we know the value of I square is how much? Minus 1. I replace. So this last term becomes 5 times 4 is 20 and 2i square. I combine. So 2i square. Next step minus 20 minus 2, 18. Let's see the next term here. This is minus 5i and 4 times 2 minus 8i. Again, both are imaginary. I can combine together, so it's like addition with a negative sign. So minus 5i minus 8i will give you minus 13i. So the final answer is 18 real part minus 13i imaginary part. So both methods, FOIL method and distributive, are very good for multiplication. You can use the method which works for you, which you find easy. Make sure you don't do silly calculation mistake. All the best. Now let's solve some more questions. Here we are now on learning objective 4. Perform operations with pure imaginary number. We'll be solving questions 7 to 12 from page 25 of your math book. Now, before we start doing these questions, I want to remind you about iota, which is the imaginary part. So remember, the value of I square is -1. And if you want to calculate more powers, you can calculate using this value. And if I take the positive square root, then the value of I is square root of -1. If you remember this much, that a pure imaginary number has iota, which is the value I equal to square root of -1, we can solve all of these questions correctly. So let's do them. The first one, if you see here, there is square root inside, there is negative. So whenever you see in the square root negative sign, you will remember it is the complex number, it is the imaginary number, and you have to use the value of iota. So if I break this into two parts, I can write 23 in the square root and -1 separately. Similarly, I can write 46 and -1 separately. So -1 is what? It is the value iota. So I can replace this and this with iota. So iota multiplied with iota is iota square. So I get iota square. Now 23 and 46, these have some common factor. I can write 23 multiply with 46. If you factor it, it is 2 times 23. So I am just writing it in this way so that in the next step, because 23 is common, I can take it inside the multiplication, and this will give me 23 times 23 times 2, and I square already I know is -1, so I can put a negative sign outside. Now inside the square root I have 23 two times, so I can take it out. So -23 times square root 2, this is the answer. Now these are the steps I do to explain you. If you feel like your calculator can give you some shortcut, you may use it, but be careful of your sign. Let's do one more to make it easy. Now this is again 6, and in the negative sign I will put separately -1. Similarly 3 separately -1. Now -1 and -1, this is iota times iota, so I2, and 6 can be written as 3 times 2, and there is already one more 3. So I combine everything together. Again, because it is square root, I can take 3 outside. Inside, I'm left with 2, and I square is multiplied, which is -1, so negative sign. This is the answer. Remember, all these 4 questions are about multiplication, so we can do the multiplication as we like. Now I'm going to use the shortcut for question 9 because I've already explained you how to do it. So I will do it like this: 5 multiplied with 10. So 10 can be written as 5 times 2. Negative and negative is 2 times, so iota square. So what's your final answer? 5 comes out, square root 2, and because of iota, negative. So -5 square root 2. That's your answer for this question. Let's do question 10. This is important. Now, if you see here, there is no square root. Only you have I. How many times? And there is negative sign also. So first multiply the number. 3 times 2 times 5. There is negative sign, so it comes outside. And now you multiply iota. How many times? 1, 2, 3. So I multiplied with I multiplied with I 3 times. Can I say it is I3? And this number I can multiply. So 2 times 5 is 10 times 3 minus 30. Now I will break my I3 in terms of I2 and I. I can break, right? So I2 times I1. Now I2 is already negative. I know the value of I2 is -1. So negative negative become positive. So this I2 I replace with negative. So negative negative positive. So 30I. That's your answer. That's how you solve question 7 to 10. This is how the answer key for question 7 and 8 looks like. I will also give you the answer key for question 9. This is the answer for question 9. We already solved it. This is for 10. We already solved it. And last but not the least, there was 2 more questions, which is 11 and 12. So these are the answer. Let me quickly solve a few of them. So answer 11 I'm doing. Answer 11 was a to the power 11. Now see, one thing I want to tell you. If I want to solve a to the power 11, I want to find the value. How I do it? For that, I will use the fact that I square is -1. So, if I try to do I4, for example, let's see. So, I2 whole square means -1 whole square, so it is +1. So remember, I to the power 4 will always give you 1. So the period of iota is 4. After power 4, it will repeat. So how can I break 11? in terms of 4. Can I write 11 as I8 times I3 because 8 plus 3 is 11, and then I can write 8 as 4 times 2, right? So when I do that, I4 is already the value 1. So 1 to the power 2 is always 1. And I3 now I can break as I2 and I1. So what is the answer? This is 1, I2 is minus 1, and there is iota. So minus I. That's how you get your answer. Okay. Let me do 12 also for you. So 4i is multiplied to minus 6i square. So we will open the bracket and then we will solve. So 4i as it is. When I open the bracket, see the power is 2. So minus 6 multiply with minus 6 and I to the power 2. Let's multiply the number. 4 multiplied by 6 multiplied by 6. So that's going to be a big number, so we will just solve it. And remember, there is negative, negative 2 times becomes positive. What is the value of I square? Minus. So don't forget. So this minus 4i, and you multiply 6 with 6, which is 36. So if you do the multiplication, 36 times 4 minus 144 I. That's how you reach to this answer. You can use calculator for shortcuts and for simplifying multiplication, but the important thing you need to remember for solving questions like 11 where the power is given is this factor. Now see, the moment you know that I4 is 1, you can solve any power. For example, if I give you I to the power 25, find the value. How will you do? Let's see. So first I need to find multiple of 4. So 6 fours are 24. So I can write I6, or better, I write I4 to the power 6. So this is 24. And how much is more left? Only 1, because I need 25. Now I4 is 1. So this whole thing is 1. So what is your answer? Only I. Any power you can calculate using this value. Now, before we go to the next question, which is from module 1, learning objective number 5, I need to revise for you the method of completing the square. So pay attention. There are 3 steps you will be doing. For any question that you get from this part, quadratic functions, the equation will be of this form: ax square plus bx plus c. It will ask you 2 things: find the value of c, and it will ask you complete the square. So the moment you see these words, the moment you see this equation, you have to remember these steps. This method which I'm now explaining is called completing the square. So remember, the value of c, the formula to do it is b over 2a whole square. Always find this number. So first you find half of b, which is b by 2. Then you do the square, which is b by 2 whole square, and then you do the result, means you add it to it and make a perfect square. Now the moment we want to make perfect square, there are 2 identities which are very important: a plus b whole square and a minus b whole square. So these algebraic identities you will learn and you will use it while you solve the question on completing the square. What is the expansion? A plus b whole square is a square plus b square plus 2ab. This you will use when there is plus sign, and this one you will use when there is minus sign. So the only difference is minus 2ab. The sign will change here. Okay, so learn these formulas, and now we are ready to solve question 5. Let's go. Okay, so let's apply the formula now for completing the squares for the following question 19. I will first solve 19 and 20 for you and then show you the answer key for the remaining question. So first we need the value of a, b and c. If you compare, your a is 1, b is 10, c you need to find out. So as I explained, to find the value of c, we need to learn the formula b over 2a whole square. You can use your calculator carefully, not making any sign mistake, to put the values and get your answer. B is 10 and A is 1. So 10 divided by 2, that's 5. So 5 square. So the value of C is 5 square, or 25. So first part is done, value of C. Now we need to do the perfect square trinomial. For that, in the same equation which is given in the question, we will now put the value of C, which is 5 square. Now observe carefully, all sign are positive. So we will use a plus b whole square, a square, b square, plus 2 times a times b. How much is a? The first term is x, the second term is 5. So a plus b whole square. That's your perfect square trinomial. Which identity did I use? Let me write again for you. A plus b whole square is a square plus b square plus 2 times ab. This is the identity I use because all sign was positive, so the perfect square trinomial also has positive sign. Now let's do question 20. Here you see the negative sign, so therefore we will be using the negative identity. A minus b whole square is a square plus b square, and the product is negative sign. Let's find ABC. A is 1, B is minus 14, and C we need to find out. I'll use the same formula. C is equal to B divided by 2A whole square. So when I put the value, carefully using calculator, don't make mistake. So B is negative, minus 14, 2 times A square. So this is minus 7 square. C value is 7 square or 49. Now you must be wondering why I changed the sign, because even if it is a negative sign with even power 2, it is same as positive. Now we put back in the equation. We've got the value of C. Now we put it here in the question to do the factor. So x square minus, there is negative sign, be careful, and C value is 7 square. So if I want to apply this identity a minus b whole square, I need the middle term. So let's change it. A square b square are easy. The middle term is minus 2 times a times b. So how much is a? The value of a is x, the value of b is 7. So I put the value and check. 7 times 2, is it 14? Yes, giving us the answer. So a minus b, a is x, b is 7, negative sign, and that's your perfect square trinomial. So this is how you do the question. You find the value of C using formula and then do the factors. Now please check your answers using the answer key. Okay, so as promised, I'm showing you the answer key. This is the answer key for question 21, which was x square plus 24x plus c. So the answer is this one. For answer 22, the answer is this one. For answer 23, this one, and for answer 24, this one. Okay, now because it is a little different and there is fraction involved, I will do one question of this type for you, question 23. So step 1, find the value of C, which is B over 2A. This time you will see it will come fraction. Compare, get your A, B, C. So your A is 1, your B is minus 9, and you have 2 also. So do the square. So if you see, the value comes out to be a fraction, which is 9 over 2 whole square. This is the value of C. Now let's put it back in this question. So x square minus 9x plus 9 over 2 square. Now if I want to apply, because there is negative sign, I will use the same identity, a minus b whole square, which is equal to a square plus b square minus 2ab. So let's use that. This is a square, this is b square minus 2a times b. This is the value of b. Okay, so I can apply in a similar way. So this will become a minus b whole square. That's how you get this answer. So I hope it is clear. Even if it is fraction, the method remains same. Please learn the formula carefully because it will not be provided in your exam, and don't do silly calculation mistake while you use the identity, and in that way you will be getting correct answer always. Similarly, let's find the value of discriminant for this question. Ax square plus bx plus c equal to 0. We know the formula of discriminant. I've already explained you. It is b square minus 4ac. Just use your calculator. Don't do silly mistake. Plug in the right value. B is the number which is multiplied to x, so it's minus 8. Be careful of sign. A is 1 and C is 16. So if you solve this using your calculator, it will come 0. So when discriminant value is 0, what is the condition? One real root which is repeated. So the value of the discriminant for question 24 is 0. The number of roots, actually there are 2 roots but they are repeated. So you will only say the number of root is 1, which is the repeated one, same value 2 times, and the type of root is real. Okay, that's how you solve it. Let's do one more, 25. Here the value of A is 1, B is minus 11, and C is minus 26. So let's get to our discriminant. Now, to save your time, because it is MCQ, I would suggest you to use calculator, but make sure you don't do any mistake while you do the calculation. So put the value of b minus 11 square minus 4 times 1 times minus 26. So this is going to be 121 plus 24 times. Just do the multiplication, use your calculator. So 26 times 4, that's going to be 104, and you add to it 121. So this is 225, which is a perfect square of 15. You can double check from your calculator. So because it is coming a perfect square, that means it will have two distinct real solutions. So discriminant is 225, which is positive, and it's a perfect square. So the number of uh, roots will be 2, and the nature of the roots will be the type of root is real. This is a formula sheet that I have pasted from your book. You are expected to learn these formulas. It will help you for solving the questions correctly. So when you find the value of discriminant, if it is positive and it is a perfect square, then there will be two real and the nature of the roots will be rational. Rational means they will be like a fraction. If the discriminant is positive but it is not a perfect square, then even though the two roots will be real, they will be irrational in nature, means they will have like this radical sign. Okay, rational means like a fraction, 1 by 2, like that. This is the first part where discriminant is positive. Now, if discriminant is 0, means b square minus 4ac is 0, it will have one real but rational root. Okay, and if you see the graph also, see in the first case, the graph touches at 2 points. Why 2 points? Because there are two real roots. However, for the second case, because there is only one rational root, it will touch at the same point only one. So here it is 2 points, here it is 1. However, if the discriminant comes out to be negative, there will be only complex root, no real roots. Therefore, the graph will not touch your x-axis at all. There are complex roots. So this is an important formula, and based on this, let's solve some more questions. Okay, so let's solve these questions which are based on the value of discriminant. So in this question, you have to do two things. Number one, find the value of discriminant. D is what for each of the question. And then after you get the value of the discriminant, based on that, you have to tell the number, what is the number of roots and what is the type of root. So let's start solving. The standard formula of a quadratic function is ax square plus bx plus c equal to 0. So if we compare, let's see how much is our a. A is the number multiplied to x square. So a is 3, b is minus 2, and there is no c, so c is 0. Let's find the value of discriminant, which is given by the formula ad is equal to b square minus 4ac. Let's plug in all the values of the function and get our value of discriminant. Minus 2 square minus 4 times 3 times 0. Now if you see carefully, here c is 0, so this term whole is 0, so the only thing which is remaining is 4. So discriminant value is a perfect square because 4 is the perfect square of 2. So the moment you get your discriminant as a positive number and a perfect square, we can easily say that the number of roots will be 2 because they are distinct roots, and it will be real because the value of discriminant is positive. So learning from the table, whenever d is greater than 0 and a perfect square, the number of roots will be 2 and the type of 2 roots will be real. They will be real roots. Now let's solve this one. Ax square plus bx plus c equal to 0. Let's write the value of abc. A is 20, B is 7, and C is minus 3. Plug in the value in the discriminant. 7 square minus 4 times, A is 20, C is minus 3. So this will be a big number. You can use your calculator to solve. 7 square is 49. Negative, negative become positive. So this is 240. So again it is 289, which is a perfect square of 17. So it's a positive number. So here in this question, you can write that because the discriminant is positive and it is a perfect square, again this question also has two real roots. That's how you solve question on discriminant. The value of the discriminant tells you how many number of roots and how many type of roots it will be. So please learn the formula. That brings us to the end of today's session. There are a few more questions left for Module 1, which I will be covering in Part 2. Please like, share, and subscribe to the channel if you found the video useful, and comment which video you want me to make next. Until then, this is Mr. Chika signing off from today's session. See you in my next video. Bye, students.